Have you ever stopped to think that when you eat might be just as important as what you eat? Today, we're getting into the science of chrononutrition, basically, how the timing of our meals can really shape our metabolic health. So, here's our roadmap. We'll start with the big problem. What happens when our eating schedule's out of whack with our body's internal clock? Then we'll lay down some foundations in chronobiology and explore this really cool feedback loop between our clocks and our food. We'll also look at a case study on genetics, talk about the real world challenges of all this, and then wrap it all up with a quick summary. All right, let's jump right in. The core issue here is what we call the metabolic timing problem. You can think of your body as this incredibly fine tuned machine where everything is on a super strict schedule. So, what happens when your eating patterns just throw that schedule completely off? Well, that's the misalignment we're talking about, and it's a conflict that can seriously increase disease risk. And here's the main idea right up front. When we eat could be just as crucial as what we eat. There's a ton of research now that shows a really strong link between eating patterns that are out of sync with our natural 24-hour cycle, our circadian rhythm, and higher risk for some major health problems. We're talking obesity, type 2 diabetes, and even cardiovascular diseases. Okay, so how does this actually work? To really get a handle on it, we need to cover the basics of chronobiology. It's the pretty fascinating science of our body's own internal clocks. The specific field we're digging into here is called chrononutrition, and it's all about this intricate dance between the timing of our meals and our internal biological rhythms. It really asks, how does this interaction guide some of our most critical functions? It turns out our bodies don't just have one clock. We're running on multiple schedules at once. We've got our circadian rhythms. Those are the roughly 24-hour cycles that govern things like metabolism, and that's our main focus today. But we also have ultradian rhythms, which are shorter, like hunger pangs, and infradian rhythms, which are much longer, like the menstrual cycle. So, how do these internal clocks actually stay on time with the outside world? Well, the process is called entrainment. It's basically how our biological rhythms sync up with our environment. And the most powerful cue for this, by far, is the daily cycle of light and dark. But here's the catch. This synchronization is actually pretty fragile. Internally, things like stress or even our own genes can throw our rhythms off balance. And externally, modern life is just full of disruptors, right? Think about the blue light from our screens late at night, the demands of shift work, or even just the jet lag from a single flight. And it's also so important to remember that we are not all the same. Each of us has a personal chronotype, which is really just your body's natural preference for when to sleep and when to be awake. You probably already know if you're a morning lark or a night owl. Now, a huge problem comes up when there's a clash between your chronotype and, life, your job, your social schedule. So, for example, a total night owl who's forced to wake up for an early start job often ends up chronically sleep deprived. This state is sometimes called social jet lag, and it's linked to a much higher risk of metabolic problem. Okay, so now let's get to the really core mechanism here, the clock food feedback loop. This is not a one-way street at all. Think of it more like a constant conversation between our body's master clock and when we decide to eat. So here's how that conversation goes. First, the central clock in our brain that controls our hunger hormones. But then, and this part is key, the food we eat acts as its own powerful timing signal for our other organs, like our liver. And what's wild is that our meal times can set the liver's clock completely separately from the brain's clock, which is set by light. The result of all this? Our meal timing can either pull everything into perfect alignment or it can create total internal chaos. And of course, when there's internal chaos, sleep is one of the first things to suffer. Sleep deprivation just throws a wrench right into our metabolism. It makes it harder for our body to handle sugar. At the same time, it messes with our hunger hormones, making us feel less full and way more hungry. It's a recipe that often leads straight to overeating and weight gain. And the story gets even deeper. This influence goes all the way down to the trillions of bacteria living in our gut. It turns out that our gut microbiome has its own daily rhythms, and they're guided by both our internal clock and, you guessed it, when we eat. It just adds another incredible layer to this whole connection. But here's the thing. What works for one person might not work for another. Our own DNA plays a massive role in all of this. So let's look at a case study with genetics that shows just how personal this whole thing can be. A perfect example is a gene called PLIN1. A tiny little variation in this one gene can completely change how your body responds to when you eat your biggest meal. For some people with one version of the gene, a big breakfast leads to more weight loss. For others, it might not make a difference at all. And here's another fascinating one. A variation in one of the main clock genes, and it's literally named the clock gene, can interact with how much healthy fat somebody eats. For patients with type 2 diabetes, this specific gene diet combo can influence their insulin resistance and even their risk for a stroke. So, if the science is so clear, why isn't everybody eating this way? Well, as it turns out, trying to apply this in the real world, it comes with some pretty big challenges. I mean, if you've ever tried something like time restricted eating, you know it is not always easy. Our social lives are often built around late dinners. Our own hunger patterns can totally fight back, and managing cravings, especially when you're starting out, can be really tough. Plus, you have to be careful to get all your nutrients in that shorter window. And here's a super common misconception: thinking that any 8-hour eating window is just as good as another. But the evidence really suggests that's not true. The timing of that window is what's so critical. An earlier window, say from 8 a.m. to 4 p.m., seems to be better because it lines up with our body's natural rhythm of being more sensitive to insulin in the morning. So, no, an 8-hour window that ends late at night just isn't the same thing. All right, let's pull all of this together. We'll do a quick recap of the main points, and then we'll do a little knowledge check to see what's stuck. So, if you take away 3 things, make it these. First, meal timing is a huge factor in metabolic health. It's not just about calories. Second, there's this constant two-way conversation between our brain's master clock and our food intake. And third, our personal genetics can be a total game changer for how our bodies respond. First question for you: how exactly does food act as a timing cue for our body's clocks? All right, question number 2. What is the main metabolic problem when your personal chronotype, say you're a night owl, clashes with a typical 9 to 5 schedule? And for our last question, can you name 2 real world barriers that make it tough for people to stick with time restricted eating for the long haul? What do you think the answers are? Leave your answers in the comments. And if you like this video, hit that like button. And please consider subscribing to my channel.